Hello, everyone. Thank you for tuning in to today's episode of What's New in Data. Really excited about our guest today. We have Hubert Dulay. Hubert, how are you doing today?
I'm very good. Thanks for having me, John.
Yeah, absolutely. We've been talking about doing this episode for a while now. I'm a big fan of your book, Streaming Data Mesh, and you gave me that special signed copy over at the Apache Kafka conference in San Jose last year, which I was honored to receive that. So we can dive into that book today. But first, Hubert, tell the listeners a bit about yourself.
Yeah, started off as an engineer, heads down, programming, mostly data and integration. Over 20 years ago, it was called integration. Now it's called pipelines and so on. But yeah, over 20 years of engineering, most of it heads down, but the latter half more in like big data and streaming data. Found myself at Cloudera and then at Confluent and Flink company called Decodable, and then now at Startree, which is a real-time OLAP database. But yeah, I've written one book so far, which is, as you said, Streaming Data Mesh. I'm halfway through another book called Streaming Databases, which I'm co-authoring with Ralph de Busman from Germany.
It's really great you're able to spend some time putting your thoughts into literature that all of us can read and learn from because you have a lot of great experience in the industry, ranging from the types of companies you just mentioned. I'd love to hear the story behind, before we get into all the concepts in your book, Streaming Data Mesh, I'd love to learn the story behind writing the book, Streaming Data Mesh.
Yeah, it was all an accident, really. When I first read the blog, Jean-Marc's blog on data mesh, I was inspired by it because it resonated with me. Part of my career was a heads down data engineer. That's really, I call it a monolithic role because everybody's sending their data at you and you somehow have to secure it, process it, govern it, and then provide it to the consumers who expect some certain SLA. And you're just like, what? You know? And when I read this blog and it was a decentralized approach to data management, I thought that's decentralizing the role of a data engineer, which I'm completely fine with. I think it's a role that has too many responsibilities. If you think of what the requirements of a data engineer nowadays, a huge spectrum of tools and technologies and programming language that you need to know. So bringing some of those responsibilities back to the domains that produce the data made a lot of sense to me as far as like, ownership of the data. They know how to secure it. They know how to transform it. Why not give them the responsibility or at least the tools to help them publish it? So when I read that blog, I thought this makes a lot of sense. And at the time I was working for Confluent and I was engaged with a prospect asking about data mesh, not even like a month later after I read that blog. I knew for a fact that some of the other SCs in the company in Confluent probably weren't read up on what a data mesh is. So I took it upon myself to implement some like a reverse go to market, right? I trained my fellow colleagues as to what data mesh is and how Confluent can contribute to it, then the field. And then that got me into people that were marketing in Confluent and then eventually to Mo, who I did my own pitch to, what a data mesh is and how Confluent supports it. And a couple months later, Jay Krebs actually coined a lot of my quotes. So it inspired me to get into kind of the space and to write a book that is related to data mesh, specifically in streaming.
Yeah, like you mentioned, there's conceptual overlap from data mesh into kind of technology overlap in data streaming, the way you can sort of decouple and decentralize your architecture, and then of course map that into the business where you can kind of decentralize the business domains of data consumption. It would be great if you could kind of walk through how streaming and data mesh are directly related.
I thought a lot about what the experience would be from a domain engineer, right? Like an application engineer. So she would be like a coder, maybe coding in Go or something, but it was responsible for sending events or some data to the analytical plane so that we could build analytics from it. What would that experience be? She probably wouldn't know Python or wouldn't know Java or Scala, the typical languages needed to be a data engineer. But there's a common language that everybody uses for data. It's called SQL, and typically, application engineers will know at least a little bit of SQL to be able to, render or at least look up data that's in a database. So what that got me to think is that how can we simplify? Because it just goes back to the self services in what a data mesh is. How can we simplify that experience for the domain engineer so that he or she can produce data and not only produce data, but productize it so that it can be consumed by many? So, how is streaming related to that? A lot of sending data, sharing data really has a lot to do with replicating data across regions, from your operational to your analytical planes. You're replicating data. And and by doing so, you're already by default streaming. A lot of your sources are going to be from streams. And if they're not, somehow it got to that site, and the data doesn't come to you in batches. It actually comes at you in real time in bits and pieces that you have to accumulate. So why not tap at the very beginning? So if the experience for the developer in the domain is to be able to use data and produce data, why worry? Why have them also batch it up and put it into files and then in bulk load it somewhere? Why not just tap it when the source happens and then let the consumers of that data accumulate and aggregate and report off of that data? So that's really the experience. Why not just take it from the beginning? Don't give them the responsibility of having to accumulate that data themselves to be shared before.
Absolutely. And now we're seeing a lot of data teams become either adjacent to AI teams or, absorbing the AI responsibilities in organizations. How does streaming data mesh support teams that are trying to get up and running with AI initiatives?
Yeah, so I just had this conversation. I think it was Kai, but I've had a with a few other people.
Is that Kai
Wayner from Confluent. He brought up the RAG pattern, which is a retrieval augmented generation, which is a pattern to help you get real time data, right? To have these models, the AI models, produce more recent answers versus, kind of stale answers. And so this RAG pattern provides a really nice pattern so that you can source new data, new corpus of data, and then create the embeddings that you need to put in your vector database, and then have these large language models use that vector database to supplement and add more to the context of this answer. So you get these large language models, you have a stream of data that's converting your unstructured data into embeddings. You're putting that in some kind of vector store. Then you ask a question of your LLM, and then the LLM incorporates that latest information to the answer. So it's really a nice pattern. I haven't seen it live. I'd love to be able to implement it someday playing, right?
I'm also sort of wading into these RAG architectures and, it seems very transformational technology, but at the same time, it's a bit incremental in terms of the actual technologies used today with, let's say Postgres adding vector extensions or
Mhm.
MongoDB adding vector extensions, et cetera. A lot of databases are going to have their own flavors of this, and it really gives your product an opportunity to highlight its strengths. For instance, Mongo's object model is a
Mm.
strength for that. Elasticsearch and OpenSearch, the open source version of Elasticsearch, are highlighting their unstructured storage layer through that. Of course, Postgres with its wide adoption. Uh, for data teams, coming back to the types of patterns that you're talking about is very foundational. Having a streaming data mesh under the hood that helps with the governance and control around domains, because you don't want your AI to hallucinate and you don't want it to give it incorrect answers. That does really require a good amount of pre-processing of the data and enforcing the data quality. And with AI, it's not like the more data you throw at it, it's gonna do better. For all the data you are throwing at it, there's some fine tuning work that needs to be done to make sure it's really resolving the types of problems that the users want to solve in their chat experience. The intents and the entities and things along those lines. So I think for that, streaming data mesh would be a powerful kind of foundational concept to apply.
Yeah, yeah, absolutely.
And I also wanted to ask you, how does data mesh compare to data fabric?
Right. This is a very popular question. And at the time of writing the book, Streaming Data Mesh, it was still a bit fuzzy as to the difference. What I was able to kind of discern was the data fabric is a lot of technical requirements that enable sharing of data, while the data mesh is like a socio or relationship between domains that share data. So there's multiple layers there. What I wrote in the book is that a data mesh actually encompasses what a data fabric is. So you can't do a data mesh without a data fabric. Data fabric kind of gives you the technical requirements, while the wrapping data mesh provides the experience and the accessibility and the governance that are required to do that ecosystem of sharing data.
And it's very interesting. I see the terms used interchangeably from enterprise teams, but they're so different, right? When you think about it, data fabric is very technology oriented, whereas data mesh is almost more ergonomic. It's a way of structuring your organization to act on
Sure.
and organize data. Now, Microsoft naming their new core analytics product data fabric is going to
Mm.
add some additional fun to industry terminology. Always great to hear about these concepts. Jumping to another topic, what are the technologies you're most excited about in our industry?
I'd say that there's a lot of buzz around Postgres. There's a lot of startups coming out of the world that are really making a lot of noise around Postgres. I think Database Insights, or I can't remember the name of the website, but they named Postgres as the number one database. I don't know if I'm excited. I'm a little excited about what's happening with Postgres, but I think I'm a bit more excited about where real time analytics is going, because there's a spectrum of analytical use cases where you need immediate, like low latency real time data versus, hour maybe real time data. Is that still considered real time? I don't know. And there is a spectrum of systems that really provide solutions to these problems. A lot of them are Postgres. So typically the rule is you don't report out of an OLTP, you report out of an OLAP database. But then you're starting to see like data like Postgres databases or HTAP databases that have these columnar OLAP capabilities. So analytics are starting to get really close to the edge. I think about like DuckDB, and then ClickHouse came out with an embeddable ClickHouse called CHDB. I see analytics being stretched all the way back to the operational plane. So when you think about like the operational analytical plane, as Zhamak kind of talked about, there's a divide there, right? That division is starting to get more and more blurry, right? And in fact, I see analytics stretching a lot further than it has been before, because everybody wants to know analytics. They want to see it in their apps. They want to see it in everything, right? And a lot of these may end up to be embeddable, analytical solutions, or depending on how much data you need to be able to analyze in those applications. I think edge analytics or operational analytics is going to be something really interesting, and not sure how those solutions are going to be put together just yet. Right.
It's definitely exciting, and I'm seeing a lot of that in the industry as well. What are some examples that you've seen of analytics sort of going back to the operational plane? And then, why does real time make an impact there?
I wrote this blog maybe a few months ago called The Streaming Plane. Basically, a lot of the streaming technologies and even the analytical technologies and workloads, they're very hard to implement in the operational plane, because you're not going to have your historical data there. A lot of times, you're not going to have the streaming processes there to be able to take it out and transform it and put it into something that can serve analytical queries. It goes back to the data mesh approach, right? When you start to take data away from the analytical plane and start presenting it at the operational plane, there's a decentralization again of analytics, right? You're bringing analytics back, not just data. You're not just giving data ownership back to the domains. You're also giving them some of the responsibilities for their own analytics, right? And if they need historical data, you need the streaming plane to actually provide the tools that the operational plane doesn't have, like CDC, for instance, transformations in real time, aggregating multiple domains together, the data products from multiple domains and presenting a real time view in that particular domain. It gets really fuzzy and it creates a cloud of data between each domains and the analytical plane. And the neatest place to organize it is back in the operational plane where we don't have the tools yet to manipulate and present that data. But I think we're still figuring out how that's all going to work. But again, it goes back to decentralization.
When you have an operational workload, someone's going to act on the data, right? And that's when, latency becomes more critical because if you have some stale data that's feeding action, it's very likely to be the wrong action or just delayed. I think about a presentation I did with the American Airlines at Data and AI Summit, and they're using data analytics, our product stream, and Databricks to basically feed these operational workloads of servicing aircrafts. And for them, latency is absolutely a critical thing to look at because time is money when those aircrafts are on the ground and are waiting for maintenance. So, that needs to be something that they take action on as soon as possible. They can't have some, batch job that's, running for, 12 hours, aggregate all the data, and then tell crews, hey, we have had this aircraft sitting on the tarmac or in the maintenance center for the last day, go service it now. These are the types of real-time operations that I think about where the latency of the data is critical. And of course, the way you prepare the data and centralize it for access within a company, because multiple consumers might need the same data for their operational use case. Maybe they need different materializations or schemas or views of the data, but ultimately it's the same underlying data. You don't want to duplicate it. You don't want to, drive up costs in your organization by saying, if I have this data set, I'm going to duplicate it n number of times for every n number of business groups that are using it. So there are smart ways. Your book gets into this streaming data mesh. It's basically, broadcast the data to multiple business consumers while keeping storage compute costs to a minimum. As data is becoming more operational, it's going to be very critical to think about these things. Teams were sort of able to get away with it in the modern data stack world. Yeah, we'll load the data into the warehouse. What we do with it and when it happens, I don't know. So I think now as we're going into this next decade with AI and operational analytical use cases, that's going to be very much the norm, right? Because when you look at how enterprises operate, their data is kind of the core piece of how they're operationalizing a lot of their workloads in a smart way. And that data is sitting in a data lake or a data warehouse, and they're trying to find ways to operationalize that. And that's where latency, governance, all this stuff is more critical than ever. I think your book is very timely and of course going to be fun to look out for your new book on streaming databases. That
Cool.
being said, Hubert, what's your future vision for the data industry?
I've been writing this book called Streaming Databases. If you just look at that term, there are two terms that go at odds with one another, like real time and batch, right? Databases are typically associated with batch, while streaming is obviously real time. But streaming databases is a conversion, I feel, of real time streams and with data at rest. And I think there's going to be more of that in the near future. Not only just because I think it's good to think of it in such terms, but I think it increases the adoption of real time and streams if you provide a database experience on your real time streams, right? And being able to see these materialized views and these tabular views of data that could be from anywhere from of in the globe that you're consuming locally, I think really advantageous. It promotes nation and it by default gives real time. I think this is a really hard problem to solve, but it feels really easy. And the vision is there. And it's a nice vision. I'm not sure that it's really that as easy to implement, but I think the technology is going to help get us there in the future.
Definitely. Hubert, where can people follow along with your work?
I have my a Substack account. You can follow all the content there is free for 3 months, and then you can pay $5 a month if you want. It's hubertdulay.substack.com. You could also find me at a couple conferences coming up. The first one will be Data Texas, I believe it's called, in mid-January. So I'll see you there.
Yes, yes, absolutely. And those links will be down in the description for those of you who are listening. Hubert Dulay, thank you so much for joining today's episode of What's New in Data. And thank you to everyone who tuned in.